Hey guys, welcome back. So today we would be starting with a new series. There would be only two videos. So in the first video we would be discussing in rate limiting, and second we would be discussing in throttling. What is the difference between rate limiting and throttling at a high level, and then deep diving into different algorithms that is there in the rate limiting. In the next video we would be discussing on the throttling part. Let's start. Rate limiting is nothing. It is just a policy that you are setting. Policy as in like let's say you have done the load and stress testing of your system, and you know my system can take 1000 requests per second or 2000 requests per second. So then in that case, that is like, you know, like this is the number, this is the capping which my system can perform. More than that my system can't handle. So then what you do is like at a load balancer level, and again this is just a high level like load balancer, but there can be multiple different places. But assume at a load balancer level you are just blocking the request. Like as soon as the request is getting, you are just counting, you are just measuring like, hey, I should be allowing only these many requests per seconds, assuming I have only one pod in the system. So if I have only one pod, 1000 requests only I should allow. That is what the rate limiting policy is. Like you are just setting a policy like more than this request should not be allowed. If more than this request happens, then what should do? Then comes the throttling into the picture. So throttling is nothing but actually muscle. Like what should happen if the policy is getting violated? For an example, rate limiting, I am setting a policy 1000 requests per second. So this is a policy. More than 1000 requests I won't be entertained. If let's say I am getting 1010 or 1100 requests per second, then what? Then throttling comes, which is an actual muscle. What it is going to do, it is going to decline the further requests. This is what actually the throttling is. So difference between rate limiting and throttling: rate limiting setting the policy, this many requests should be allowed. If let's say one pod can handle 1000 requests, let's say you have 10 pods, so you would be saying like 10,000 requests per second only I would be allowing, not more than that. If more than that I am getting a request, I would be throttling that request, that is I would be declining that request. Now let's deep dive into what are the different segments are there where we can put a rate limiting policy. So first is an API level, then the second is an IP base. What does that mean? That means it's like, okay, there is certain IP, let's say, so from this particular IP address I should be allowing only, let's say, 50 requests per second. Just again a hypothetical example, 50 requests per second. The benefit of this is basically a lot of bots are there, or people try to break your system by brute forcing or by spamming by too many requests and stuff like that. So you are blocking the request at an IP level only. So that is an IP based rate limiting. Like for that particular IP, only these many requests per second should be allowed. Then comes the user type. So we have, let's say you have seen a lot of gaming applications where like you can log in as a guest user, then you can log in as a social account, become a proper member, or again like you can become a premium member by doing a paid membership or whatever it is. So then now there are different user types or user categories. So now we are saying like, hey, he's just a guest user. So now for guest user, because he is using my service for free of cost, I would, let's say, want to allow him only like, let's say, 100 requests per second. But let's say if he is a paid user, then for paid user, let's say I would be allowing him 500 requests per second. So this is at a user type. Then comes the account type. Again, at an account type there can be multiple things. Okay, silver account, gold account, platinum account, whatnot, like different account types are there. Based on that, we are going to allow them the request per second. Like, okay, only this many requests you are allowed to use. So that is at an account type. Then comes the location type. Different regions are there, like India, USA, Russia. Let's take an international example. So what we can do is in that particular cases is like, okay, from India if we are getting requests from this particular regions, overall I can allow these many requests, but from Russia I can allow only this so and so requests. From Pakistan I can allow only limited set of requests. So now at a location level also we can mention like, okay, from this particular location from these many requests should be allowed. So these are the different segments on which we can apply the rate limiting policy. Then we would be discussing on an algorithm. So there are 5 different algorithms. What is the purpose of algorithm? So now let's say you are setting a policy, you are setting a threshold. Like, okay, my system should allow only 1000 requests per second or 50 requests per second or whatnot. So this is management is setting a threshold. But how exactly you would be knowing like this threshold is reached or this threshold is breached? Basically, once the threshold, so first part is, so let's say first part is setting a threshold. Then second part is ensuring threshold is valid. And then final part is, if invalid, then throttle. So this management engineer, whoever is there, he is going to set this thing. Now threshold validity. So now this threshold validity is where rate limiting algorithms comes into the play. This is going to ensure whether your request per second is under that particular threshold or not, and post that if it is invalid, then throttling is going to come into the picture, which we are going to discuss in our next video, where if the threshold is breached, that we are going to throttle the request. So now let's discuss on algorithm. So there are 5 algorithms: token bucket, leaky bucket, sliding window, fixed window, and sliding lock. First we would discuss on token bucket. So assume this is a bucket, there are certain set of tokens that is present. Okay, so now let's say the capacity is let's say 100 requests per second. So one request is equal to one token. So means 100 tokens per second, per minute. Let's take this example, per minute. So now what happens is, there is a bucket, and in that bucket there is a 100 token. At the start of a timer there is a 100 token. Now what happens is, let's say user is now sending a request. So now here your rate limiting algorithm sits, and it is checking like, hey, if I am having any token available in this bucket, if it is available, consume the request, allow the request, and then deduct one token from the bucket. So initially if it was 100, I got one request, token is available, I consumed that particular request, and I deducted from 100 to 99 tokens. Like this, so and so forth it happens until the time when all the tokens are consumed. Let's say all the 100 tokens are exhausted, my bucket is empty, and I am getting 101 requests. I will see whether the token is available. If the token is available, nice. If the token is not available, in this case token is not available, I would throttle that request. Basically I will drop that request. Again, like throttling is having again a different stuffs, but just consider like I would not entertain that request, I would drop that particular request. Now what would happen? After 1 minute, again there is going to be refilling of the token is going to happen. So now there were 100 tokens, those all got exhausted. After 1 minute, again new 100 tokens are going to get added. This is how token bucket algorithm works. So now let's look into some nodes part of it. So first it is used in spike or burst. For example, let's say I am having 100 tokens. Okay, and then suddenly I got a surge of 50 requests in second 1, and then again 50 requests in second 2. So now in this case, because there is a 50 request, I have a token available here. Directly I would be doing 100 minus 50, and I would be serving those requests. Then I would be doing 100 minus 50 and serving those requests. Suppose that if any new request is getting, I am not going to entertain because I do not have the token. So in the spike cases, it is again helpful. As soon as you are getting a spike, you have the tokens available, you are directly consuming those tokens. So this is again helpful in the spikes in the burst scenario. Then second is new tokens are overflown. What does that mean? So let's say I was having 100 tokens initially, I have used 40 used. So now left is 60 tokens. So now after 1 minute, refilling happens. So now refilling 100 will happen. Already the left is 60. So only the refill will be 40. 40 would be refilled, and this 60 would be overflown. So at one time we are going to ensure like for that 1 minute in that bucket there should be only 100 tokens, there can't be more than that. If more tokens are getting added, those are going to be overflown, those are not going to be present in the bucket. So it is again like a most popular algorithm that is being used. It is being used in AWS API gateway. So most of us we are using AWS as a cloud provider. So there we are using AWS API gateway. So for them the rate limiting, they are using token bucket. Google Cloud Endpoints NY proxy are using token bucket as an algorithm for the rate limiting. Then we would be discussing on leaky bucket. It is firstly mostly outdated and less popular, but still as part of discussing all the algorithms, we will discuss leaky bucket as well. So how exactly this works? So here assume there is a queue and there is a counter. So now there is a queue. In queue we are saying like this is a bounded queue. Bounded queue like as in only those many requests are entertained or allowed in that particular queue. More than that the queue is full and no new requests are accepted. So now queue size is there, it can accept 100 requests only. Rate limiting policy 10 requests per second. So now I am getting 100 requests, I am saving it in the queue, but my RPS is 10 requests. So don't assume like my queue size is equal to my RPS. No, queue size is different, RPS is different. So 10 requests per second is there. So now how does it work? Let's say on 9:19:1, like this is the first second, 10 requests was removed. So let's say my queue is having 100 requests already. On 9:19:1, 10 requests were removed from the queue because it is having 10 requests per second. So every second 10 requests will be deducted from my queue. So 10 requests removed from the queue, pending request 9. Then 9:19:2, that is the next second, again 10 requests is removed. So now my pending requests are 18. Then in the third second, what would happen is again 10 requests is removed. So when 10 requests is removed, previous was 80, 10 was removed. So now 70 is pending. Now what is happening is at that third second, again I am getting 40 requests, 40 new requests I am getting. So 40 new requests is getting added. So now 70 I am having plus 40 is equal to 110, but my queue size is 100. So only I would be allowing 30 more requests in the queue. So now total my queue size would be 100 and the remaining 10 requests, it is going to be declined. This is how leaky bucket algorithm is going to work. Now let's discuss on the next algorithm, which is a fixed window algorithm. So assume like it works based on the window. So at a DSA level, you might be aware about the sliding window, fixed window. So there is a window is of like a particular time frame that we are setting. In this case, let's say 0.1 to 0.2. So like 1 minute window is there. Now what we are saying is, and a hypothetical example, in 1 minute my capacity is only 3. Like in 1 minute I can just entertain only 3 requests. My system can entertain only 3 requests. So now how does it work? So you see like 0.1 to 0.2, there are total 5 requests. 3 requests were entertained, 2 requests were discarded. Obviously this is on the first come first serve basis. So whichever request is coming, I am entertaining. More than that I am discarding. In 02 to 03, I am getting 3 requests. My capacity is 3 requests. I am serving that. In 03 to 04, now this new window, my capacity is 3. I am getting 4. I am just entertaining 3 and discarding the 4th one. This is how fixed window works. So let's deep dive into description. 1 minute window, 100 requests per minute is our rate limiting policy. So in 1 minute we would be entertaining 100 requests. Now there is a counter that I am setting. Counter is equal to 0. So at the start of every minute, here my counter is going to be 0, here my counter is going to be 0, here my counter is going to be 0. So now initially my counter is 0. Now as soon as in that particular 1 minute, as soon as I am getting more and more requests, I am incrementing the counter for every new request. So now if counter size is greater than 100, then I would be declining the request. So assume in this case 0.1 counter is 0, 0.1 to 0.59. Now what happens is like till this 59 seconds, there is absolutely no request. On 59th second, within the 1 minute window, I got 100 requests. So now immediately my counter spiked to 100. Perfect. And it is again like well within the limit. Now what would happen is on 0 to 00, again because it is the start of a new 1 minute time, I am going to set my counter to 0. Now what happens is on 0 to 01, again new 100 requests came. So again my counter for the second window is 100. So now in this case you see 02 to 02, like the next second I am getting 10 requests and I am declining. So now why this is happening? So assume basically this window and this window. So here and here I am getting 100 requests, here I am getting 100 requests. So now because it is well within the counter limit, I have entertained that. But now you see this 59 seconds and this 59 seconds. So you see out of 2 minutes, that is 120 seconds, this year and this year, I got 200 requests. And because of a spike, and I have entertained that. But now this 59 seconds there was no request, and now in this 59 requests, any new request I won't be able to entertain because now my counter is full. So this is the problem majorly with the fixed window algorithm. Even though it is easy to implement, but in cases of spike on the edge of the window, this creates a problem because now here if all the tokens I am exhausting, I won't be able to entertain any new requests for this remaining time of this particular window. So issue with the above is post 2.0, any new request for next 59 seconds will be declined, which leads to request imbalance and starvation. So now let's discuss on a fourth algorithm, that is sliding log. Let's say a window of 10 seconds is there. I am keeping a window and every window is of 10 seconds. Now capacity of a window is equal to 3. That is only 3 requests are consumed in 10 seconds. So basically what is my rate limiting? What is my RL rate limiting? It is like 3 requests per 10 seconds. Request 1, time 0, window. Here what I am going to do is I am going to log the timestamp of every single request that I am getting. In all the previous algorithms that we have discussed till now, nowhere we are noting down the time, we are just noting down the counter or the tokens. In this video, in this particular algorithm, we are going to note down the time of every single request that I am getting. So in time 0, I got first request, my window. In, let's say this is an array and I have put 0 seconds. This 0 means like, okay, there is first request and currently in my window, it came at 0 seconds. Now request 2 I got in time 4, like after 3 seconds, on 4th seconds I got a new request. So now my window 0, 4. Now request 3 I got it in on 8 seconds. So now my window 0, 4, 8. 3 requests within 10 seconds, that 0 to 8, like within 10 seconds 3 requests I got and I have entertained that. Now assume request 4 I am getting. Request 4 I am getting, time is 9. So time is 9, what am I going to do? I am going to decline the request. Why? Because capacity. In 10 seconds, so even though we are in the 10 seconds of a window, 0 to 9, so we are in the 10 seconds of the window. But the problem is, because my window size is exhausted, it should entertain only 3 requests and already I am serving the 3 requests, so I would be declining this request. Now request 5 I am getting on 11 second. 11 second means till now this was my 10 second window. Now what happened is like my window slided here and now this is my new 10 second window. So now what it would work? So 11 minus 10, that is 1. What exactly this means? So 11 means 11 seconds when I got the request. 10 means window size. So 11 minus 10, 1. What does 1 signifies? 1 signifies means from this particular window, look back and see all the requests that I received before 1 second and just delete those requests from that particular window. Delete those requests as in like delete those representation or the references of those requests from this particular window. So before 1 second, there was only 1 request, that is 0. So what I have done is like window 4, 8, 11. Now I have added this because I have removed the 0, 4, 8, 11 and still the capacity is 3. Understand this thing properly. Let's take one more example. Let's say on request 6, time is 19. Request 6, time is 19. What does this mean? 19, that is the time when I am getting a request. 10, size of a window. 19 minus 10 is equal to 9. Means from this particular window, delete all the references of those requests they have received in our system before 9 seconds. So here 4 and 8. These are the 2 requests which I received before 9 seconds. So this is setting a bar basically. Like before this particular time, remove all the requests. So now what would happen? 4, 8 and 11 was there. Window, I removed 4 and 8. Only 11 was present. I entertained this request 19. So now my window size is 2 and it is again like well within the 10 seconds of the window. Now assume again in 19th second only. 19th second only I received a request 7. Again same formula, 19 minus 10 equal to 9. Remove all the requests which is before 9 seconds. In this window, my very first request is of 11 seconds. It is not before the 9. So, and again like my window size is valid. So, I would be allowing one more request to be entertained and here I am putting the 19. Means like this is the new request at 19 seconds I have received. So, this is how sliding log work basically. Very critical. Go through this video once again for understanding sliding log. This is very much important thing that you need to understand. What is the problem? First, it is very much complex to implement. Second, because every time we are maintaining the request timestamp, it is taking more and more space. So first it is complex to implement and second it is taking more and more space. That is the reason it is rarely used in the highly scalable system. Less people or less companies are using this particular algorithm. Then our final algorithm is sliding window algorithm. Now this is again like one of the popular. So previously we have said like token bucket is a popular algorithm and again like this is the second most popular algorithm among the industries that people are generally using for deriving the rate limiting policies. So now sliding window. Why it was created? It was created to overcome the disadvantage of sliding log. In sliding log we have a sliding window. So sliding log. What it is meant up of? It is sliding window plus request timestamp. Okay, this is sliding log. What sliding window is? Sliding window is just sliding window. We are just eliminating this request timestamp. Because of that, we are reducing the complexity first, and then second, we are reducing the space that is utilized. That is what the sliding window is. So now let's go into an explanation. And this is, in my opinion, like I felt it to be a bit trickier for people to understand. So go through this explanation one more time after my initial explanation to understand this in much better sense. So explanation. So let's say 1 minute window time frame is there. In sliding log, let's say it was 10 seconds. Here we are taking 1 minute window. Like again, like it depends on application to application. Just for an example purpose, we are taking this thing. 1 minute window, 10 requests per window. Means 10 requests per minute is what we are going to entertain. Fine. So let's check now 0.1. This is my start. 0.1 minute and seconds. 0.1. 0.1 I got request 1. Here again I am using a concept of counter to eliminate this request, but I need to track. So what I am using is I am using the counter. So initially at the start my counter is let's say 0. 0 1 0 0 request 1 I got. Let's say a counter is there. Counter A got incremented to 1. Counter value is 1. 0 1 59. I got 7 requests. within this particular 1 minute of a window on 59th second I got 7 requests, my counter has reached to it. Cool, fair enough. Now what would happen? 0 to 0 0. Assume there is a B counter is equal to 0. Assume there is a B counter is equal to 0. 0 to 0 0 there is a B counter set to 0. 0 to 0 6 I got 3 requests. From 0 to 0 6 I am going to look 1 minute back. So 0 1 0 6. So this is my 1 minute window. And now in this 1 minute window, I have to ensure like there are going to be 10 requests only, because my rate limiting is 10 requests per minute. So this is my 1 minute window. I need to ensure like there is only going to be 10 requests. Okay. So now here what we are doing. So here we need to apply a mathematical formula, and that's what I mentioned. Like this is going to be a bit trickier. In this 1 minute window, I am going to ensure like only 10 requests should be entertained, not more than that. If less, okay, but not more than that. So now how am I going to do that? I am going to apply this formula. 1 minus percentage passed into A counter plus B counter. It is complex. Just bear with me for certain minutes. So let's take an example. 0 to 06, 106, 1 minute of a window. 01 to 02, that is 1 minute 60 seconds. 02 to 106, that is 54 seconds. That is 90% of the window. Because it is 60 seconds is equal to 1 minute. So 6 seconds. Correct. So 6 seconds of 60 seconds is equal to 90%. Correct. So now what we are doing is 02 to 0106. 02 to 0106, that is 54 seconds, that is 90% of the window. So what we are doing is 90% of the A counter plus B counter. Assume we are at 0 to 00. 0 to 00. Request received? No. So B counter value is 0. Why? Because I received a request on 0 to 06, not 0 to 00. So initially my B counter value is 0. So now what I am saying is, hey, in my last window, my A counter value is 80. My A counter value is 8. But because I am going to take only 90%. Why 90%? Because if I am taking 01 to 02, it is going to be 1 minute. Correct. But I am taking 0106 to 02. Which is going to be 54 seconds, which is going to be 90%. So to be fair, what I am saying is, hey, in my this 1 minute window, there was 8 requests. Okay, there was 8 requests. But because I am not taking right away from 0100, I am taking from 0106. So I would be taking 90% of my A counter. So 90% of my A counter I would be taking. My A counter value is 8, not 80. So my A counter value is 8. So 90% of the 8 is 7.2. So you see now the thing is from 0100 to 0200, there was 8 requests. But because I am taking my window from 0106 to 0200, I am taking 7.2. So I have declined my counter value. Like I am saying like, hey, in this particular window, I have just received 7.2 requests. 0106 to 2.0, 7.2 requests I have received. Now assume I got a request on 0 to 06. I got 3 requests. Okay. So now take a wholesome window. 0106 to 0206. This is 1 minute window. Okay. Out of this 0106 to 02, 7.2. So now remaining for 6 seconds. How many requests I can take? 10 requests as per my rate limiting per minute minus 7.2. So technically I should entertain only 2.8 requests, rounding off to 2, because I am taking a flooring value. So rounding off to 2 means what? Means in this particular window I should entertain only 2 requests. So 7.2 plus 2 is equal to 9.2. I should entertain only 2, which is less than 10. So we derive to this 2 value. But on 0 to 06, I got 3 requests. We received 3 requests on 0 to 06. So B counter value is set to 2, as only 2 requests will be consumed and 1 will be declined. So now we are declining 1 request. The ultimate purpose is, what we need to achieve is, we need to achieve this threshold value. So let's say now if I am going to like 02 to 018, if I am taking. So now I would be looking back 01 to 018. 01 to 18. Now this is going to be my 1 minute window. So now on 02 to 018, when I am getting let's say X number of requests, what I need to understand or I need to come up is I need to identify the threshold. Threshold means like from 0 to 18, I am looking back 1 minute, 18 to 0 to 18, how many requests I should entertain. How many requests I should entertain. So now how am I going to derive that? So assume that 0 to 00 to 01 18. 0 to 00. So let's check for simplicity complex. Let's avoid the simplicity in calculation. Let's check this thing. 0120 0220. So now 0120. So this is like 40 seconds. So 40 seconds of this particular window out of 60 seconds of this particular window. 70% for an example. So 70% of a counter. So 70% of a counter, that is 70% of 8 requests, because my a counter value was 8. So 70% of 8 requests, that is 5.6. So now for this particular window 0120 to 0220, 10 minus 5.6 is equal to 4.4, which is rounding off to 4. So I can entertain only 4 requests. I would like to conclude the complete rate limiting part. If you feel I have added something valuable, then please do consider liking this video, sharing this video as much as possible, subscribing to this particular channel for such videos, and commenting if anything you feel like I have said something wrong or some improvement is needed or some appreciation. Please do comment it in this particular video. Thanks.